Hi everyone, good evening. I'm Gauri, one of the solutions architects based out of Seattle. Thanks for coming over to our session. I know this is probably last session of the day. Hope you'll have some takeaways before you hit the casinos or pubs today. I would like to also introduce my colleague, Fernando Dingler from Fresh Team. So before we start, just a quick poll. How many of you are from retail industry? Because, oh, that's a good number. And how many of you probably have worked or experienced with serverless architectures like Lambda, Dynamo DB? Cool, decent size. So today I'll be talking about how certain retailers are already achieving greater results on AWS. I will also introduce you to the benefits of serverless architecture so that you can decide how to take advantage of this architecture for your needs. And of course, I will talk about some of the services that are used in serverless. The second part, Fernando will talk about Amazon Fresh serverless architecture and the best practices that they have followed. I'm sure most of the retailers like yourself may be dealing with brick and mortar as well as online sales model. Today is, what is special today? Cyber Monday, right? There is a lot of traffic to your e-commerce platform. How do you ensure you're able to meet your customers' demand throughout the year, whether it is Cyber Monday, Black Friday, Christmas, Mother's Day, or any other day? And while doing that, do you want to spend a lot of money in capital expenses as opposed to operational expenses? And what kind of apps do you want to deliver quickly to your customers so that you can differentiate yourself and stay ahead of the competition? And what about analyzing your data, customers' data, no matter where they are coming from, understanding what they want and making appeal to them? As a retailer, these are all things you desire, and certainly AWS can help you with. If you look at some of the retailers for running their workloads on AWS, for example, Brooks Brothers, they are a US-based fashion retailer. They're able to test and launch new features much faster than before. There is another retailer in UK, Made.com. They could handle the peak without any disruption by running the critical applications on AWS. These are just to give examples how retailers are already achieving greater results. Let's move on. Based on our experience, retailers are focusing on three particular areas. To start with e-commerce or digital commerce, you may have some platform that is scattering customer traffic coming from omni-channel, like web, mobile, Android, iOS, and point-of-sale system. The second is about big data, analyzing customers' data. No matter where they're coming, whether it is big or small, whether it is structured data or unstructured data, petabyte scale or terabyte scale, you really want to analyze your customers' data to understand and to gain some insights for your business, as well as to provide some recommendations for your customers. We are delving into digital customer experience. Amazon is doing a lot of work with Alexa. A lot of our customers are building voice and chat interfaces and using applications like digital shopping assistant, chatbots, leveraging machine learning kind of technologies to talk to customers and understand what they want. Not to mention IoT, Internet of Things for automation of your stores and delivery systems and so on. Imagine what kind of technologies or infrastructure that you need to build and manage to make these things work. Our answer is, you don't need to. AWS has been continuously expanding its services and features. We have about 90 plus services across various domains: servers, storage, databases, machine learning, big data, to name IoT, that allows you to build virtually any type of workload to meet your business requirements on AWS. If you look at one of the major retailers in Nordstrom, they have built a near real-time data processing system that provides personalized recommendations to their customers. Not only that, they're able to do this much faster. Like, for example, they were able to provide these recommendations in seconds than which used to be in minutes, and with a lower cost. If you look at the type of the customers who are deploying their workload on AWS, we see a lot of customers use EC2. I think most of you are probably familiar with it. EC2 is most like a de facto choice, especially when you are migrating from on-premise to cloud. And we see a lot of retailers use EC2s to deploy applications like digital commerce tracks like SAP Hybris and IBM Vespair Commerce and so on. And we have a lot of instance types to support wide range of use cases. On the other hand, we have Amazon ECS, Elastic Container Service. We have seen customers like Expedia and Upserve. They are leveraging ECS to run microservices using Docker containers. And we see a lot of customers using long-running applications, batch jobs, using ECS. Interestingly, there is a good trend of customers started leveraging what we call a serverless compute, also known as Lambda. What is serverless compute? It's all about building and running applications without thinking about servers. So you don't have to provision, manage, or patch the servers. You don't have to worry about high availability or scalability of the servers because AWS will take care of for you. All you need to do is develop your application, develop your code, and upload it. So we have a service that will execute your code, and the service called AWS Lambda. There are a number of ways you can trigger Lambda. I will talk about it in a while. I have mentioned about Nordstrom's recommendation story. So they have used AWS Lambda and other managed services to build that capability. So likewise, you could also build many real-time data processing applications using Lambda and other AWS managed services to serve use cases such as like clickstream analysis, recommendation engine, and social media analysis, IoT analysis. So many such data processing applications you can do. And also you can build a backend applications for your e-commerce stacks, like web backends, mobile backends, IoT backends, and so on. You can also use chatbots, build chatbots, and Alexa-enabled applications using this serverless computing model. I mentioned about the retailers focus area. So many of those focus areas you can leveraging serverless computing model. Let's look at some of the advantages of serverless compute. Of course, it helps you to focus on your core business logic because there is no servers to manage. This way, it helps you to release your application much faster. So you can release new functions and features to your customers much faster. Additionally, it is cost effective because all you are paying is only the time when your code is executed and the number of times the code is executed. When the code is not executed, you are not paying for anything. And it automatically scales to your workload, especially valid for retail use cases because you have a spiky workload. So these are some of the advantages where we see a lot of customers started thinking about serverless computing model. Let's look at the typical components of serverless architectures. Any serverless architecture starts with a Lambda because Lambda is kind of a central backbone, and that is where your core application logic runs. How do you trigger Lambda? There are a number of ways you can trigger Lambda. You could have a streaming data that can trigger Lambda, or there are event sources. So event sources are nothing but other AWS services that emits events, and that events can be captured and processed by your code in the Lambda function. And what you do with the Lambda, it purely depends on your application logic. You process the results and store in another data store, for example, Amazon Dynamo DB or S3. Or you could call another Lambda function or another APIs and so on. So let me give a simple example how you can use our serverless architecture. It is very common in retail industry, you get some kind of updates. It could be product updates and pricing updates from your vendors or partners. And you want to update your customer database so that you can provide the latest information to your customers. Let's say the file which contains the updates is received in our storage service, S3. As soon as the file arrives, you can trigger a Lambda using a feature called event notification. So inside the Lambda, then you can process the file and then store the results back in DynamoDB. This is a simple use case. So likewise, you can implement many such architecture using serverless architecture pattern. Today, I'll be talking about one of many serverless reference architectures. This is serverless web mobile applications. Why I have chosen this architecture? The reason is this is what Amazon Fresh has leveraged to address their customer needs. Let's look at this architecture. So we are leveraging Lambda and AWS Managed Services API Gateway and DynamoDB to provide a completely serverless applications. So with Lambda, with other managed services, you don't have to worry about managing the infrastructure. And it is automatically scales, and it's fully managed. In this case, your customer traffic you are receiving customer traffic from omni-channel, like web, mobile, and other sources. The request gets landed into API Gateway. API Gateway processes the results by calling Lambda. It calls the Lambda, and Lambda processes the request. And based on your logic, you can store the results in Dynamo or give the data back to the caller. So this is a simple use case. This is how you serve the dynamic content for your web applications using this architecture. You can also add additional functionalities, like if you want to provide static content, you could use S3 to store your static content. You can use our CloudFront service to provide caching of your static content close to your users. So this is a sample architecture. Let me dive deep into some of the services that are used in this architecture. To start with Lambda. Lambda, we talked about, it's serverless compute service. The good thing is it supports most commonly used programming languages like Node, Python, Java, and C#. So you can write any of these programming languages with Lambda. And the way we trigger Lambda, I talked about event sources. So just to give a perspective, like a new file comes, it can trigger a Lambda. A new message comes, it can trigger a Lambda. So you can architect in different ways. These are all a list of event sources that are natively integrated with AWS. And the list continues to grow. Almost most of the services have some level of integration with Lambda. One important thing to highlight, it is not necessary you trigger Lambda through event sources. You can also schedule Lambda, like a cron-like expression. So you can have Lambda to run a particular time of the day to serve use cases like taking extracts or sending some kind of notification on a particular time. Or even you can use Lambda to do some IT policy checks. Those kind of use cases, you can use schedule Lambda. Working with Lambda, it's very simple. So all you need to do is when you write your code and when you upload to the Lambda, what we call is we create a function. So when you create a function, you have to specify the memory requirements for the function. Lambda supports memory rating from 128 MB to 1.5 GB. So based on that, appropriate CPU and network resources are allocated. So it's very important to choose the right memory allocation for your application needs. How to do that? The best way is to test different memory configurations based on your needs and choose the right value. There are other important considerations when you are building your application using Lambda. The first is Lambda is a stateless service, so you cannot expect to store anything inside Lambda. So you need to use other data stores such as S3 or DynamoDB to store the state. And the maximum processing time or the timeout you can have with a Lambda is 300 seconds or 5 minutes. So if your application needs more than 5 minutes to process or it's a long-running applications, then you may want to consider EC2 or ECS. Lambda is not the right fit for your use case. And it has features like it supports versioning of your code and also like operational parameters. So you can define configuration parameters such as table name, the bucket name that are used in your code outside of Lambda, you can configure as a parameter so that you can refer it inside the code and manage different environments like dev, test, and so on. For monitoring Lambda, it's natively integrated with our CloudWatch service. So you could look at statistics like the errors, number of invocations, and a lot of such metrics you can monitor in real time. And it also integrated with the CloudWatch logs, so whatever logs you are writing, it gets recorded in CloudWatch logs. Deploying Lambda, it's as simple as that. You write your code and upload it to the console or through CLI, or you can implement a sophisticated CI/CD, like continuous integration, continuous deployment kind of a pipeline using other AWS services. For example, you could use code pipeline for orchestration and code commit to store your code and code build to build your Lambda function and so on. Typically, serverless architecture is not just Lambda, right? In this case, we talk about Dynamo DB, API gateway. There are other managed services. How do you provision all the resources that are required for your serverless application? You can use CloudFormation for that. So using CloudFormation, you can provision all the resources and manage them. And even you can create parallel environments, or you can create equivalent environments in another AWS region for disaster recovery and so on. So CloudFormation is the one which you could use for that. We also have another interesting service, X-Ray. Using that, you can understand the performance of your applications, especially when you're working with serverless and Lambda. You want to trace what is your request latency. How much time it's taking to call from Lambda to DynamoDB. How do you trace those kind of end-to-end requests? The X-Ray provides that capability. So with that, you can troubleshoot and understand the performance aspects of your application. So we talked about Lambda. Moving on to the front-end layer. We have Amazon API Gateway. It's a fully managed service. Again, it's a serverless for hosting your HTTPS endpoints on AWS. It acts like a front door because you have a Lambda or some service running on EC2. API Gateway more acts like a front door and routes your traffic to your backends to get your data or to process something on your backend. And it allows you to, it provides capabilities such as hundreds and thousands of concurrent API requests, traffic management, authorizations. All of these features are managed out of the box. So you don't have to handle this in your code. So API Gateway provides these capabilities as a managed feature. You could create APIs, publish, configure. You can implement a lifecycle of APIs using the API Gateway. And also you can have something called stages. So you can have different versions of your APIs to support your application release lifecycle. For example, different versions for different environments like dev, test, and so on. It has another interesting feature called throttling and usage plans. It's probably useful for retail kind of workloads. So you want to restrict a single consumer or a partner. You can have only X number of API requests per second. So you can do that using what we call as the throttling and usage plan. So you can create an API key for that consumer, and you can set thresholds, like he can have, let's say, 1,000 requests per second. You can also set up quota, like he can have only 100,000 requests per week. So this is something you can define as part of API Gateway service. And like Lambda, it is integrated with the CloudWatch for real-time monitoring of all your API requests and so on. Let's look at sample API call flow, how it would look like. So before that, when you define an API endpoint, there are two types of endpoints you can create. There's a regional endpoint, and there is an edge-optimized endpoint. The regional endpoint feature is actually quite new. It just released this month. So it is mainly for scenarios where you have an EC2 instance hosted in a region, and you have an API gateway also in the same region, and they are talking to each other. In those kind of scenarios, you may want to go for a regional endpoint. If you have consumers or developers who are global-based, then you may go for an edge-optimized endpoint. So this is the default, and the edge-optimized endpoint would use CloudFront distribution in front to route your traffic. So in this case, a sample API request you get the request from different sources, it gets to the internet, and from internet to the nearest CloudFront, our content delivery service upon edge location. From there, it gets routed to the API endpoint where it is actually hosted and get served from there. You could also configure a caching on top of your API gateway. Optional, it is an optional thing, so you can configure caching at the API gateway. So if there is a cache, it gets served from there. If not, it goes to the respective service and try to get you the data and so on. So we discussed about the front end. What about the data layer in serverless architectures? It's a very commonly asked question. So we see there are a lot of retailers use NoSQL data store for range of use cases. So shopping catalog, probably you guys more familiar with. So there's also like inventory data, product catalog, customer data, order data. There are a number of use cases you could use NoSQL data store. Let me talk about some of the advantages of using NoSQL data store. First of all, scaling and performance, right? Performance at scale. So I talked about Cyber Monday. So we are talking about a lot of traffic. So you should be able to provide a consistent response to your customers, whether it is Cyber Monday or normal day. With the NoSQL data stores, with the horizontal partitioning, it's easy to scale. Because the SQL data stores, there is a limit that you can scale vertically. Additionally, there are some operational activities that you might need to do. For example, like query plan changes that could affect your performance, or indexes that you need to keep rebuilding to get the optimal performance. So those things you don't need to do in NoSQL data store. Additionally, if you look at, I talked about digital customer experience, right? So if you need to build your applications to provide that level of capabilities, your data store should be able to receive and process data at much faster rate from variety of data sources. Here I'm saying variety means the data could come from social media, the web, mobile. So there are many sources and different formats of data that could come. So your data store should be flexible enough to receive those data and show it to your customers. A simple example is, let's say you're running a promotion, and based on the market feedback that you want to add some additional attributes to your data model to capture some extra attributes. How to do that? With a flexible data store, it's easy for you to ingest more data with a different format with minimal changes to your application to consume the data. And Amazon DynamoDB provides all of these capabilities out of the box. So again, it is serverless, so you don't have to. So building and running your own NoSQL data store is not an easy task. So Amazon DynamoDB provides this out of the box. That's why even Amazon.com, one of the retailers, they have used DynamoDB to serve millions of TPS in the last Prime Day 2017. In fact, there is a blog about that. Now, there is another retailer in Tokyo Hands. They have built a cost-effective shopping system on top of DynamoDB. These are some examples how other retailers are leveraging DynamoDB. So let's look at some of the features of DynamoDB. DynamoDB is a NoSQL data store. It supports key value as well as document data types. And it also has features like indexing, like global secondary indexes and local secondary indexes that provides additional search capabilities on your data. And it is highly available, durable. Any data that you store in DynamoDB, it gets replicated across 3 facilities within a region. So that way it's highly available. And I talked about consistent high performance even at a high scale. Like I talked about Amazon.com's Prime Day, like millions of TPS. So DynamoDB provides a single-digit response for your gets and puts. Like any data you read and write, you get a single-digit millisecond response consistently. From security-wise, it has a natively integrated with your identity and access management service. So even you can implement a fine-grained access control. Like you can have a restrict users to restricts at the table level, or within the table, you can even restrict at the item and attribute level. So you can create an IAM policy to do that. And we are talking about serverless architecture. DynamoDB is natively integrated with a Lambda using a concept called triggers. So whenever there is some change happens, let's say you have a table and there are some data change happens, you can capture this change and process it via Lambda. So there is a concept of trigger and DynamoDB streams. Using that, you can achieve that functionality. And it's cost effective. The way you work with the DynamoDB, you provision the capacity, right? So you provision the read-write capacity. So when you provision, for example, for peak events, you want to provision high capacity to serve the needs. But after the peak event, you don't have to provision the same level of capacity. So you can scale down to a normal traffic. So that way it's completely flexible. Let me also highlight some of the other interesting features that we released on DynamoDB, especially this year. To start with, DAX. It's called DynamoDB Accelerator. It's a kind of an in-memory caching service in front of DynamoDB. It's a fully managed service. Why would you want to use DAX? Again, from retail point of view, if you look at, you can use to cache your popular items. There are certain deals or certain items going to be more popular. So you can serve from the cache, DAX. In this way, you can reduce the number of reads that you are using on DynamoDB, and you can save some cost. And DAX provides microseconds response. Just note down. While DynamoDB provides milliseconds, DAX can provide a microseconds response for your gets. So that's another advantage you may want to consider. And typically what you see, there is a lot of data that grows, right? In any industry, it's also valid for retail. How do you manage the data growth? So for example, you are running a promotion, like after 6 months or 1 year, you don't want to probably look at the data quite frequently. So we call this data like a cold data. So as a best practice, it is not a good idea to keep the cold data in DynamoDB. So you could move the data into other data stores such as S3 for those kind of scenarios. How to achieve that? So we have a feature called time to live. So what you do is you will designate one of your attribute in the table as a time to live attribute. Then DynamoDB automatically expires those items or purges those items which meets those criteria. So that the TTL is the flag that you set, and you specify using a timestamp, basically in epoch format. And DynamoDB automatically purges the items. You can capture those items and move into S3 using DynamoDB streams. And there is another interesting feature called managed auto scaling. I talked about scale up and scale down. So if you want to handle an infrequent spike in your workload, you could use this feature. So what you would do is you will set up some minimum and maximum threshold, and DynamoDB will automatically scale within the range so that it helps you to meet infrequent spikes as well as to save cost. So these are some of the useful features I would request you to consider while building your applications on top of DynamoDB. So we talked about serverless architecture. We talked about the technical aspects of Lambda, API Gateway, and DynamoDB. Now I would like to invite my colleague Fernando, how they've used these architectures to improve their customer experience. Over to you, Fernando.
Thanks, Gowdy. Good evening, everyone. My name is Fernando Dingler, and I'm a software engineer at Amazon Fresh. Well, first of all, I'd like to know how many of you here are Amazon Fresh customers or have tried it in the past. All right, I see a few hands. Cool. So you may relate yourself with this presentation. So Gary already provided an overview of what what components are part of a serverless architecture. So I'll be showing one of the stories of how we leverage serverless architectures at Amazon Fresh. If you don't know what Fresh is, for those that didn't raise their hand, it is a grocery delivery service for Prime members. You can buy online from a selection of produce, and you can have your groceries delivered within the same day, or you can choose a future delivery date. And if you haven't tried it, when you get your groceries delivered, they come in these green reusable bags that we call Totes. And the idea of these bags being reusable is that once you're done unpacking your groceries, you can put them back on your doorstep, and they will be picked up on your next delivery. However, sometimes happens that the delivery trucks are full, and so they can't take any more totes. They simply don't have any more room. So what happens is they'll end up leaving the new totes along with the previous ones from your previous orders. And it was creating an inconvenient situation for our customers. because it wasn't happening that often, but it was happening often enough to have some customers unhappy. And these totes can be bulky. They're about this big. And if you live in an apartment or a small place, it's kind of annoying having to hold them for a week or so until your next delivery. And that's exactly what was happening. Customers were not happy. Like this person who posted a picture on Twitter. It says, I love Amazon Fresh, but it doesn't look like they will ever pick up my totes, even though I've asked them twice. So he built a Christmas tree out of them. And he wasn't the only one. There were other customers complaining as well, like this one or these other ones. So it was clearly becoming a problem, and we wanted to fix it. You may relate yourself with this slide in the sense that I'm sure that at your organization, you also have one process that is very manual or very tedious. And this is how our process looked like before we changed it. Essentially, when a customer was faced with this issue of not having their totes picked up, what will happen after is a series of multiple steps, multiple people involved, customer service representatives, pickup specialists, transportation teams, and eventually their totes will be picked up. But it's a lengthy process. It was not transparent for the user. It will take within 3 to 5 days, so really not ideal. So we wanted to improve it. We wanted a better solution, something where the customer can have a direct way of requesting their totes to be picked up. And what better than a UI with a one-click button from the mobile app? A UI where the customers can go, where their address is already pre-filled, and where they can click one button and forget. Their totes should be picked up within the next day. And that's the solution we built. And like all of you guys in this room, and same for us, when we start a new software project, we care about non-functional requirements. And we all care about these ones, right? Everybody cares about time to market. Everybody wants their infrastructure to be easily managed. And everybody wants their project to be cost-effective. And like my colleague Gauri already mentioned, these are one of the features that a serverless architecture highlights the most, more so than other architectures. And that's why we decided that a serverless architecture was appropriate for this project. Oops. This is how the architecture of the solution we built looks like at a very high level. So I'm going to start diving into each of the layers of this architecture. Gauri already gave the overview and the theory of how the services work. I'll give implementation details and share some of the best practices we followed on each of them. But before that, I'll just give you a quick context on what the team had to build around this project, which was called the Totes pickup service. There were 3 requirements that the team needed to build. And I'll start with the first one, verify eligibility. What this means is we needed to know when the customer lands on that UI, whether it's the mobile app or the website, we needed to know if the customer is eligible to request a Totes pickup. And the process looks like this. First, we check if the customer has already a request pending. Because if they do, then they're not eligible, right? They can't duplicate a request. If they don't, then we fetch their last fresh order, and we check if it has been delivered. Because if it hasn't been delivered, then there's no need to request their totes to be picked up, because hopefully they'll be picked up when that order is delivered. And if it has been delivered, then they're eligible. That means the button will be enabled on the UI. They can click it. And this is an interesting slide because it highlights that you can build a serverless solution that can coexist with your existing retail systems. So the first step of the flow runs on the serverless solution the team built. And the second step runs on existing retail system for Amazon Fresh. The second use case is when the user actually clicks the button, when they schedule the pickup request. And the process is very simple. There's a request that goes to the backend, goes through the API layer. There's a Lambda function that will serve the request. It will save the data to DynamoDB, and then it will send a notification to the internal transportation systems to actually schedule the pickup request in the customer address. Notice that the address of the customer is already pre-filled in the UI to make it easier for them. And the last use case was around reporting. Essentially, the business team wanted to know things like how many customers are requesting their totes to be picked up, in what regions, what transportation systems are we using, things like that. And you probably already know that you can build reporting capabilities on AWS in a number of ways. For us, we decided to leverage CloudWatch events and Lambda functions. So essentially, there's a Lambda function that runs on a nightly basis as a cron job. And CloudWatch event takes care of this. So when this Lambda function gets triggered, it pulls data from DynamoDB. It will create an Excel spreadsheet that will get saved to S3 for historical purposes. And then it will also be sent via email as an attachment to the business team. This was simple enough, and it met our requirements. But you could very well go more sophisticated and put the data on S3 and use Athena, for example, to query it. All right, so I'll be going to each of the layers and the services that we use, and I'll share some of the best practices. Starting with the data layer. The team chose DynamoDB, and primarily, obviously, because it's a managed service. It is serverless. But before we chose it, we had to analyze our access pattern requirements, and we identified 3 of them. We needed to get the pickup requests by customer ID and address ID, but we also wanted to get the pickup requests for a given customer in all of their addresses. And we also wanted to get the pickup request for a given time range for reporting purposes. We also care about having a flexible schema and being able to deal with JSON documents very easily. And for this case, we only created one table in DynamoDB, and we called it the Totes pickup request table. This is where all pickup requests get saved, and this is an example of an item in that table. Notice that the partition key we've chosen is a composite key of 2 attributes. It is the customer ID concatenated with the address ID. And this allows for a quick lookup of pickup requests for a given customer in a given address. But it also turns out that it's a great partition key because it provides, since both of those attributes are UUIDs, it provides a good level of randomness that will provide an even data distribution across our DynamoDB partitions. The sort key is the creation datetime, and it allows basically to store multiple pickup requests for the same customer in the same address, but at different times. Now, it's very likely that just with the partition key and sort key, you won't be able to satisfy all of your access pattern requirements. You may end up creating indexes. And that's what we did. We created 2 global secondary indexes on the table. The first one allows us to get the pickup request for a given time range. And the second index on the slide allows us to get the pickup requests for a given customer in all of their addresses. Once you define your indexes, your partition key, your table, you have to define the throughput capacity. And if you're not familiar with DynamoDB, it is defined in 2 ways, read capacity and write capacity. It essentially determines how many reads or writes you can do per second. And you can define this in 2 ways. You can either provision a hard-coded number, or you can leverage DynamoDB auto-scaling. And you provide a range, and DynamoDB will scale within that range. And the way we determine our capacity was very simple. We considered these 3 factors. We identify our access patterns, like I showed, the reads and writes. We measured the item size. Essentially, what's the average size in kilobytes of an item in the table? Oops. And we worked with our business team to make an educated guess on how many pickup request we think we were going to get when the service launched. And this is going to be helpful to estimate the throughput capacity. So let's go through an example of how you can estimate write capacity. So let's say that we had to support 10 Totes pickup requests per second, 10 TPS. And let's say that one item on our table on average is 3 kilobytes. We know that one write unit, it's equivalent to 1 kilobyte per second of write capacity. So we can do the math very easily. It's 10 TPS times 3 gives us a total of 30 units per second. This means that we need, at a minimum, 30 units of write capacity to support our demand. But if we leverage DynamoDB out to scaling, we can set a minimum to 30, and we can set a maximum to 60, for example. And that's how you handle with sporadic traffic spikes. Now, something very important, even on a serverless architecture, is to always monitor the services you use on AWS. And CloudWatch is a great service for this. So for us, we think that for DynamoDB, these are the 3 metrics that you should care the most. And I want to make particular emphasis on the first one, the throttle requests. This metric is telling you how many requests are being throttled due to not having enough capacity, throughput capacity. So you should set an alarm on this. Because if you ever get, let's say, for example, more than 10 throttle requests in a period of 5 minutes or whatever makes sense for your use case, you want to get notified so you can adjust the capacity appropriately. And it's important to highlight that these metrics have to be configured on a per table basis as well as on each global secondary index. Now, as far as best practices that we followed on DynamoDB, I'll go over a few of them. We chose a partition key that provided an even data distribution, like I showed. You want to avoid attributes with low cardinality. You want to avoid sequential numbers, for example. You want to have attributes that provide a good level of randomness. We used global secondary indexes to satisfy all of our access pattern requirements. We also estimated the throughput capacity by considering workload and item size. And the way we handle sporadic traffic spikes is by leveraging DynamoDB out to scaling. We also use the document client, which is part of the AWS SDK for Node.js. And it handles JSON documents really easily. And it also has the nice feature of doing automatic retries on throttle requests. And we leverage CloudWatch for monitoring. Now, moving on to the compute layer of our architecture, the Lambda functions. The team ended up writing a total of 6 Lambda functions. And I want to highlight a few things on this slide. The first time is the runtime environment. Notice that we chose Node.js. And the only reason for that is because we have seen that it provides the best cold starts out of all the other environments. Notice that the first 3 functions are triggered on a synchronous way, whereas the last 2 are triggered on an asynchronous fashion. The first one are triggered by API gateway from our user interface, and the last 2 take care of the reporting, essentially. And that leads me to the next thing, which is the timeout execution. For those functions that are triggered synchronously, you probably want to set a low time on those. Because, at least for us, it meant that there's a user waiting for a response on those functions. So if you want to have a good user experience, you want to have those functions to be executed quickly. That's not the case for the asynchronous execution. You can set the maximum for those, for example. You can set it to 5 minutes, because you don't really care whether they take 10 seconds or they take 5 minutes, because they run on an asynchronous fashion. There's no caller waiting for a response. And the last thing to highlight is the memory allocation. You probably already know the more memory you allocate, it will determine how much you pay per millisecond on Lambda. But one thing that a lot of people don't know is that when you allocate more memory, you get a larger CPU. So your functions might run quicker than if you allocate less memory. So the advice is less memory is not always cheaper. You got to play with the values and see what works best for your workload and try to balance cost versus execution time. Expanding a little bit more on the two different execution models that we used, I want to highlight the error handling on each of them. The synchronous one, for us, API gateway, the UI is calling API gateway and trigger the Lambdas. If Lambda fails on that execution model, the caller is responsible for retrying the operation. That's not the case for the asynchronous execution. In that case, if your function fails, AWS will retry the execution by default 3 times. And if it fails more than 3 times, you can configure now a dead letter queue. So your execution can be sent to that dead letter queue for further analysis. And the same thing like with DynamoDB, we also monitor our Lambda functions. And we think that these are the 3 metrics that you should monitor on your functions. The first one, errors. It essentially tells you when there's an error in your function. Most likely, it means that there's a bug in your code. So you also want to set an alarm on this one, because if there's a bug in your code, you want to fix it quickly, right? You don't want to have your functions failing. So an example on alarm could be if you ever get more than 5 errors on a period of 10 minutes, you want to get notified. The second metric is the invocation duration. This one is particularly useful to monitor for those functions that you care how much time they take to execute, the synchronous ones, for example. It tells you essentially what's the duration in milliseconds of your functions. And you should care about the average on this one. At least we recommend you care about the average statistic. So an example alarm could be if the average execution time exceeds 750 milliseconds, you'll get an alarm. And the last one is also very important, the throttle invocations. There's a limit of how many concurrent Lambdas you can run, and it is set to 1,000 by default. So if you ever exceed this limit, your functions, your executions will be throttled. So you also should set an alarm on this. As far as best practices, we followed on Lambda. We divided them into design and operational. I'll start with the design first. The team wrote 1 function per use case, like I showed. We wrote a total of 6 functions, as opposed to 1 single monolithic Lambda to handle all of the use cases. This is a best practice. We separated the Lambda handler, essentially the entry point, from the core logic. This allows you for easier testability. We used environment variables to pass operational parameters. That's pretty obvious. You want to pass things like DynamoDB table names or S3 bucket names or whatever it's specific to each environment. And a lot of people don't know that if you put a Lambda on a VPC, it will impact the cold start time of your functions. So you want to avoid placing them on a VPC if you don't have to. Unless the function needs to access a resource like an RDS instance or something that it's within a VPC, then you should avoid placing them on a VPC. As far as operational best practices, we set CloudWatch alarms on throttle invocations and errors, like I showed you. You want to use dead letter queues to handle those failures on asynchronous executions. You also want to be aware of the concurrency limits. Like I mentioned, there is a limit of how many concurrent Lambdas you can run by default. Simultaneously. And it is set by default to 1,000. So if you think you're going to exceed this limit, you can reach out to customer support and adjust it accordingly. We also leverage CloudWatch events to schedule Lambdas as cron jobs. Now, the third layer of our architecture is the API layer. And again, the team chose API Gateway primarily because it's a serverless service. It is managed. But it also provides a really smooth integration with Lambda functions. You can create endpoints, RESTful endpoints, and you can have your UI call these endpoints and execute functions whenever they are invoked. These are the ones that the team created for this particular project. API Gateway is also very secure, as every endpoint is by default HTTPS. And it also has some really nice features, like, for example, we can track requests coming from the mobile app versus requests coming from the website by giving them different API keys. So this is a really nice feature. And finally, the last component of a serverless architecture, it's the provisioning and management of it. And you can leverage CloudFormation for this. The team created one stack that creates the entire infrastructure for this project, from IAM roles, DynamoDB tables, S3 buckets, API functions, API endpoints, Lambda functions. The whole thing gets created with one CloudFormation stack. And you can define this, and it's a great way to have your infrastructure managed as code. You can also do deployments with this CloudFormation template. So that's the journey of the different layers of our architecture and how we solved the Totes pickup problem with a serverless architecture. And here are some of the results I can share about this project so far. Obviously, the first one is we ended up with a better user experience. Now we have a UI where the customers can go, if they ever face this issue of not having their Totes be picked up, they can go to this UI, their address will be already pre-filled, they can click this button, and their Totes will be picked up, most of the times within the next day. But in a few areas, it can take up to 3 days. With this, we saved hundreds of hours on customer service time. And the team that built this project did it in a period of 3 months, from development to production. And it was actually a smaller team than the average team size of Amazon. And according to internal surveys from Amazon, a team that owns a serverless architecture tends to spend 3.7 hours less time in operational work compared to a team with a non-serverless architecture. So I hope that this story shows that you can improve those manual processes in your organization and that you can adopt serverless without having to rewrite your existing retail systems. Thank you very much.
Thank you, Fernando. So now you all know the trucks may do the pickup, but it is actually the Lambda that does the magic for Totes pickup. So yeah, serverless is kind of a new normal. It's fast and cost effective to develop applications using serverless. And it helps you to be focused on your customer's problem, like in the case of Amazon Fresh, and stay out of all operational issues and challenges. Thanks for your time. We really appreciate your time. Thanks for listening in. We'll be around. If you have any questions, feel free to drop.
Thanks, guys.